Hi guys, this is the last video of our unit. This is 4-12. This is AP Calculus. And this video is for the weekend of Friday, December 16th. No homework. This example is from the 2002 AP Calculus AB free response section. And there were actually more than just two. I think there were 3 or 4 parts to this, but I only included the first 2 parts because we won't know how to do the others until later. So here it is. An object moves along the x-axis with initial position x of 0 equals 2. Okay, so the position function would be x of t. All right, the position function would be x of t. That's how they would write that function. The velocity of the object, that would be the first derivative of position, at time t is greater than or equal to 0 is given by this function. So they're giving you the velocity function. Part A, what is the acceleration of the object at t equals 4? So you just need to know your facts. Acceleration is the second derivative of position, but it is the first derivative of velocity. It's the rate of change of the rate of change. So for A, I'll just make the observation that the acceleration at any time t is equal to the first derivative of velocity. You would need chain rule here. The inside function is pi over 3t. The outside function is sine of blank. So the derivative of pi over 3t is just pi over 3 times the outside function. The derivative of sine of blank is cosine of blank. But what goes back in the blank, whatever was in there to begin with. So pi over 3t. All right, so that's the acceleration function. They want to know the acceleration of the object at time t equals 4. So I'll just go acceleration at 4. And then you want to make sure that you're in radians. So always be in radians in AP Calc. And I'm in radians already. And I'll just go pi over 3. And this is from a calculator section. Pi over 3 times cosine of, I'm plugging in 4. So of 4 pi over 3. And I end up with this. All right, so this is negative 0.5235. Okay, and this is the rate of change of velocity. Velocity changes. The units on velocity are, in this case, are they even telling us? No. Okay, so I guess we don't have to give units because they're not giving us units. All right, never mind. So, all right, there's that. So that's part A. Part A is done. Now part B. Consider the following 2 statements. Statement 1. For this time interval from 3 to 4.5 seconds, I'm just assuming, the velocity, I don't know what the units are, but the velocity of the object is decreasing. Okay. Statement 2. For the same time interval, the speed of the object is increasing. Okay. So, guys, another way of saying the speed of the object is increasing is to say speeding up, all right? So the speed of the object is increasing. That would be, it is speeding up. Are either or both of these statements correct? For each statement, provide a reason why it is correct or not correct. Alrighty, so I want to know if the velocity of the object is decreasing. Well, this is where you have to know this table like the back of your hand. And remember, this would be another way of saying this is position, velocity, acceleration. So velocity, they want to know when the velocity is decreasing. Well, the velocity is going to be decreasing when the acceleration is negative. Okay, so the first derivative decreasing means the second derivative or its derivative is negative. So I just have to ask myself if the acceleration is positive or negative on this interval, okay? So I already have the acceleration function. Okay, so let's graph it. We have our graphing calculator. So I'm going to go to y equals, and I'm going to graph the acceleration function, and I'm going to see if it's positive or negative on that interval. So I've got pi over 3 cosine pi over 3 x, and I'm going to change my window because I only care about this time interval from 3 to 4.5 seconds. And then I know the amplitude of this is not that high, so I'm also changing the y min and y max so I can see it better. Okay, so as you can see, this is the acceleration graph. Okay, I graphed the acceleration. On this interval, it is completely below the x-axis. It is completely negative. So the answer is that statement 1 is true because I'll say because the acceleration, which I'll be real clear, is the derivative of velocity, is greater, no, it's not, is less than 0 on this, or I'll say on, I'll say just like they did for 3 less than t less than 4.5. Yeah, and I think that that's good enough. Okay. Yeah, because we have, if the derivative of velocity is negative, the acceleration is negative, then that means that the velocity is decreasing. And then for statement 2, I have to think about this. For the same time interval, the speed of the object is increasing, so it's speeding up. So you have to know that, back to the first page, you have to know that in order to determine if the speed is increasing or decreasing, or when the particle is speeding up or slowing down, you have to look at the signs of velocity and acceleration together on that interval. Now, I just said that the acceleration is negative on this interval. So it'll be speeding up, the speed of the object will be increasing, or it will be speeding up if the velocity is also negative on this interval. So I'm going to say for part, yeah, we're still in part, statement 2. All right, so let me do some investigation first. So the velocity, I just have to look at it. I just have to go here. All right, so that was the acceleration function. I already graphed it, saw it was negative on the interval. Now let me graph the velocity function. So far, so good. There's the velocity function, also completely below the x-axis on our interval of interest, so also negative. So, so for part C, still the same part. Statement 2, Roman numeral, is also true because A of t is less than 0 and V of t is less than 0 for that interval. Okay. All right, so there's that. Now, let's do this one last example of the unit. So, I don't know what, I don't know, I don't think that this was an AP problem, but it says free response there. And we can use our calculator. So the table represents data collected in an experiment on a new type of electric engine for a small neighborhood vehicle, one that is licensed for travel on roads with speed limits of 30. Okay. The readings represent velocity in miles per hour. Okay, so these readings here are the velocity, miles per hour, taken in 15-minute intervals on a 2-hour trip. What is the average acceleration over that interval and include units? And here you just have to know that acceleration is the rate of change of velocity. Well, how do you, so we want the average rate of change of velocity. This is a velocity table, so we want to find the average rate of change for this table on this interval. Okay, so we're going on this time interval. So from there to there. And here's their corresponding outputs. So I'll say that the average acceleration is going to be equal to v of 0.75 minus v of 0.25 over 0.75 minus 0.25. That's just the average rate of change formula, which is equal to, I already did this, and I got 5. Okay, so if you plug in all the values, you'll get this. So we get 5 miles per hour per hour. Okay, that's an hour. Which is 5 miles per hour squared. Okay, so acceleration has those types of units. Okay, guys, that's it. There's a lot to know this unit. Just work on your flashcards and you will be just fine. If you know your facts, this will be a breeze. Okay, see you soon. Bye-bye.